Hi, everyone. My name is David, and I'm a developer, and I live in Stockholm, Sweden. So it's about 3 p.m. here in Stockholm. It's a really sunny day. And I'm going to talk about a fresh take on monorepos in Python. And I'm thinking about having this talk in sort of like three parts. First, I'm going to go through some terminology, because I think there might be some confusion between these words. And then also I'm going to talk about something called Polylith and what that is and what it can, how it can help us as developers. And I'm also going to do some coding and showing some examples, and that part I'm a little bit extra nervous about. Okay, so let's kick off with monorepo. What is that? Well, repo, that's short for like repository. And from my perspective, I think a monorepo is a place where you put your code, some version control, like a Git or GitHub repo. And the monorepo means that you put all your code in that repository. You might have one or several apps or services in there, but it's one and the same repository. And there's also something called monolith. And before I started to dig in a little bit deeper into this kind of things, I almost put an equal sign between monorepo and monolith. But a monolith, that's more like the actual thing that you deploy and install somewhere, like a service or an app. And monolith means that all the features of that thing that you deploy lives in one and the same app. So you deploy everything. When you do change at one place, you deploy the entire app again. But from like the other side is something called the microservice. Or microservices, and that's sort of the opposite of monolith, because a microservice is usually a part of an ecosystem or part of a platform or an app. A monolith contains everything. A microservice contains parts of that. So let's say that you and your development team are building some sort of e-commerce platform, maybe, and one part of that would possibly be a way to handle incoming orders, and another part would possibly be products, how you deal with products, how you add and remove products, and a third part of an e-commerce platform would probably be something about pricing, maybe calculating prices and taxes and stuff like that. So in a monolith, everything would live in one and the same app. But with microservices, each of these would be separate things that you deploy on different places, and they can be like several different programming languages. But and I guess normally they are either like REST APIs that communicate with each other through REST, or maybe some sort of event-driven system that sends messages, consumes and produces messages between them, like AWS, SQS, or maybe even Kafka. So that's kind of the difference between, as I see it, monolith and microservices. And monorepo, that's just the place that you store the code. And I think, from my experience, joining a couple of teams working with microservices, because I think microservices are a really good idea. But from my experience, the kind of most common case that I have seen is that when you develop code, let's say that you have a order service, which is a REST API, you put that in one repository, then you have your other parts of the system in its own repository. So you have a ecosystem with several repositories. That's at least the common case that I have been working with. And that comes from my experience with a couple of trade-offs. And a couple of them are that with several microservices and several repos, you get code in several repositories, and that can be difficult, a lot of information to unpack for one individual or one team or an organization. So that could be a trade-off. And another one that I have been reflecting on is that it's quite common that some code is duplicated. You can recognize patterns and even sections of code in several of those repositories. So you have some amount of duplication, maybe boilerplate code, maybe some implementation or infrastructure code or something like that. So, but the code that if you have several microservices and you share and you have found code that is used on several of them, what is quite common is that you extract that code and create a library for it. But then you have then you probably will put that library in another repository, so you have even more repositories. And another trade-off, as I have from my experience, is that dependencies and sometimes even Python versions will differ between the different repositories, because maybe you cannot give every repository full attention constantly. Maybe your team is focusing on one feature living in that service, and other services may have gone stale. So these are some trade-offs that I have noticed with the microservices pattern. And the bottom line that I see that it can be a lot to maintain. So there's a thing called Polylith that actually addresses these trade-offs. And Polylith, it's actually, you see the symbol you see next to the Python symbol is actually the Polylith logo. And Polylith is an architecture with tooling support that addresses these issues with microservice. The thing that I brought up with having duplications, a lot of code spread out in several repositories. But Polylith is a monorepo thing. So it has ideas on how you can structure code in a monorepo. Another thing, if we zoom in a little bit in what Polylith actually is that it's kind of a different take on how you view, how we can view code, or Polylith views code in a different way than I have seen before. So a thing that if you would read the Polylith docs, you will probably see the word Lego a couple of times in the documentation, because Polylith uses that idea of Lego bricks, and it sees code parts of the code, maybe even features as as something that you can combine and build something out of. And it also has kind of a separation between what is your own Lego bricks, the code that you develop, and the things that you use that lives in third-party libraries. So in Polylith, there's basically libraries, bricks, and there's also something called projects. And projects is the actual things that you want to deploy and install and run somewhere. So a project could be one of these microservices. Let's say that order services, if you would build that e-commerce platform. So one or more projects lives in a Polylith monorepo. And the good thing with this is that it has solutions for how to share code between the different services. As a matter of fact, all the code that you write is ready to be shared. And this is an example of how a Polylith workspace would look like. And what workspace in Polylith is basically the root of your Git repository. You might say that it's that the same thing. So a workspace in Polylith would have these basic folders, this basic structure. And I think I forgot one thing. If I step one step back, you might have noticed there were different colors of these bricks, green and blue, and the gray ones are the third-party libraries. So because in Polylith, we have the bricks, but we have two types of bricks. So we have something called bases, and that's also like sort of the Lego analogy, because if you have built some maybe a house, Lego house, you usually start with a base plate where you put your Lego bricks on and start building something. So a base in Polylith would be something like that base plate in Lego. And then you have your green things, which are the components, which contains the actual features that you build. So a base could be, let's say that we are going to build a REST API. In the base, there will be the endpoints to that API, and the actual implementation, the code that does things behind that endpoint, would be one or more components. Oops. So, and the structure, coming back to the workspace, the structure is that you put all your bases in a bases folder and all your components in a components folder, and then you have one or more projects that you put in a projects folder. And in the projects folder, you don't really have any code there. It's only the infrastructure needed to define what's in the project. Basically a PyProject TOM file, and maybe deployment infrastructure, like if you have a continuous integration or Docker files and things like that. So you would put that in the projects and all the code in the bases and components. There's also development folder. I'll come back to that shortly. Actually, I come back to that right now. Because another thing besides that Lego thing and the monorepo thing with Polylith, a huge part of Polylith is the developer experience. So the idea is that it should be really simple to experiment and try out and develop new bricks, or which is the Lego bricks, bases and components, and try them out and try to build features combining these different bricks. So when you develop and when you open your code editor and start writing some Python code, you're not really navigating down to a single project and working there, but you are rather at the workspace, the Polylith workspace root. That's where you have your virtual environment. And that virtual environment contains all the code for all of the projects. So basically all components, all the bases. And that means that you have access to all code in the one and the same virtual environment. And that's really good if you like trying out things in a repo, for instance, or maybe you experiment with Jupyter notebooks and stuff like that. So you have your developer set up, you write code, and then you can also define the individual projects. So actually, the development folder you can see it as a separate project, but a special only for you, for your development team. Okay. So who made this? So this thing is an architecture, but also with tooling support. And this architecture comes actually from the Clojure community, which is a very vibrant and a community coming up with new, fresh ideas, and has inspired other languages like the JavaScript community and Python community and yes, languages like that. And the team that made this are these three: Joachim Tengstrand, Furkan Bayaktar, and James Trunk. And they have also developed and developing and maintaining that tooling support for it. So, and that's Clojure. So what has that to do with Python? Well, there's something called the Python tools for the Polylith architecture. And that's a thing that that I have developed. I haven't developed the architecture. That's Joachim and Furkan and James. But I have developed a tool set for making this architecture work well in Python. Because I used to be active in the Clojure community, working with Polylith projects, and really liked it. And then I came back, when I came back to Python, because I had working full-time Python before too. Then I came back and joined teams that had this microservice setup, and I could really recognize these trade-offs, and I was thinking, wow, it would be really nice if we had that Polylith thing in Python. And so I kind of did some research and didn't really find anything that was existing in the Python community. So I started to write something something for myself. So, and this I'm thinking about switching to my code editor and a shell to demo how it works and what it looks like. Okay, so this is my code editor. I use Emacs because I like that. So I have an example repository, Python Polylith example. This is on GitHub. If you want to look at it later, I can share the link. So you see that I have this setup, the Polylith workspace setup here. I have a basis, components, that development folder, projects, and also a tests folder. So the basis contains two bases, and the components actually only contains two components too. It's a really tiny repository, but I made it I just wanted to have it as simple as possible without too much code. You see that it has some /demo, and that means that all code in a Polylith workspace has one and the same top namespace. So what we're actually adding when we're adding components and bases is a namespace packages, what we call namespace packages in Python. There's also the development folder. I'll come back to this one later. Later you see that it's a file with my name, which might look a little bit weird in the beginning. I'll come back to that. And then I also have, I think it's two projects. I have an AWS Lambda project, and I have a Fast API project. I really like Fast API. So you can see here that what that project contains, this folder contains is the PyProject toml, the actual configuration of the project, and the log files, and also a Docker file if we want to run the app in Docker, if you prefer that. So there's not any Python code in here. All Python code lives here in that in the components and bases folders. So I'm going to head over to my shell here, or the terminal, because I want to demo the actual tooling support. So what we saw before in my code editor was actually the structure, but you would very likely want some tool to help you out with keeping that structure and picking the right top namespace and things like that. So what I developed was a tool that is actually a plugin to Poetry, and I really like it. I guess you know about Poetry. It's a very nice tool to keep track on dependencies and install things and virtual environments, and even packaging your product. So I found really good things in Poetry and decided to make an plugin to make it to enable the Polylith architecture on it. So you start your commands with Poetry. There's a poly, and I'm going to run the poly info command. And what that gives us is a summary of the workspace. For this tiny little example repo, it's not that much, but we can see that we have two projects, we have two components, we have two bases. And what might be more interesting is that we can also get an overview of what bricks are used in which kind of project. So you can see that the log message and messages lambda is used in this project, but not the greet API. That one is actually used in the fast API project. So we get an overview of what kind of code is used where. So that can, I'm thinking about, yeah, I'm going to show another command. Oops. There's another command called polyliths, and that one will scan your workspace and look for any third-party libraries and where they are used. And in my tiny little example repo, we have one brick only that uses one third-party library, and that is actually fast API. So I'm going to switch to a different repo that is not that much code, but it's a little bit larger. So I'm going to run polyinfo on it. And this repository contains 3 projects. It has 5 components and 3 bases. You can see that the API app here uses these kinds of, these ones, but not the fetch data brick that is used by the worker and things like that. And if I'm going to run that polylibs command on this repo, you can see that the API app project uses these libraries, Pika, PyMongo, and Fast API, and the other, the worker project uses these third-party libraries. So you get a quick overview on what's in this repository. I'm going to switch over to a slightly larger code base. And this might be a little bit meta, but this is the actual tool itself, that itself is a Polylith repository. I know this is a little bit weird, but you can see that this one contains one project, which is the plugin that I have developed. And that one has 16 components and 1 basis. And 1 base. So you can see that all code in this workspace is actually used by this project. If I run polylibs, you see that the entire workspace has a couple of dependencies. It uses Poetry because it's a Poetry plugin. It uses TOMLkit because this project kind of reads TOML files and analyzes dependencies and things like that. And it also uses the great rich library that makes CLIs that you can write build CLIs with like nice colors and things. So that's an overview of this of this repo. And there's actually another command called polydiff. So you start every command with poetry and then poly and then the actual subcommand. And this is a thing that you can use to see if, let's say that you're developing something, you have one or several projects, and you change one or several bricks, and you want to find out which project is actually affected by this change, and which project would make sense to redeploy. So this command is probably most useful in a continuous integration environment. So you change your brick, one or more bricks, and you push it to your repository and ready to merge it. And then with the Polylith tool, you can get information about which ones of these projects that you actually should redeploy. So you have the full control over the deployment, but you can ask Polylith, hey, which projects is affected by my changes here? So it will display that for you with using this command. I'm going to jump up one step and the Python Web Conference 2023. So let's say let's say that I'm going to start from a blank sheet. I'm ready to start a new project, new coding project, and I've heard about this Polylith thing, and I want to try it out because I have these kind of experience, these kind of trade-offs with microservices, and I want to give this thing a try. So I've started a brand clean folder. There's nothing in it like that. So so what needs to be done? What I really like Git, so I'm going to make this folder a Git folder, Git repository. Put running Git in it. Done. And the next step is to, because we use with this tool Poetry, so I'm going to run the Poetry init command, which will launch a guide that will ask for some basic information for you. Maybe it's an open source project. I can select Python version if I have any dependencies, but I'm not caring about that now. Great, this looks perfect. So now I have one single file, a TOML file that defines my new repository. So now that's done. So now I want to initialize or create a new workspace. So there's a poly create command, and you say that, and I want to create a workspace. And I'm going to give it a name. This is quite important because the name of the workspace will be the top namespace for your bricks, your namespace packages. I think I'm going to name it Python Web Conference 2023. And I'm going to select a theme also because you have the option to have different kinds of structure. And the loose theme is the one that I think is best for Python, at least if you use MyPy and tools like that. So if I run ls to list the contents, you can see that I have my basis, components, development, projects, and also a Polylith specific configuration. But the basis folder is empty. The components folder is also empty because I don't have anything. So I can already now start to ask what's in this repo. So you see that, to no surprise, I have 0 project, I have 0 components, I have 0 basis. So I'm about to start writing some code. And what this architecture, this type of architecture allows you to do as a developer or developer team is to choose from where you want to begin. You're not forced into to define a project because maybe you don't know what the output is going to be. Is it going to be a REST API or maybe a set of serverless functions on AWS Lambda or Google functions or anything like that? So if you don't want, you can actually delay that design decision and start writing the features. And then when you're ready for it, you can start thinking about project infrastructure. So you can choose from where you want to begin. And I usually like to begin straight into like the feature itself. So I'm going to create a component because I have an idea of writing some sort of messaging system or something like that. It's the same command, poetry, poly, create, but this time I want to create a component and giving it a name. So I'm thinking about some sort of thing that actually returns, I don't know, hello world or something. Greeter. That sounds good. So if we take a look, it still looks quite the same. If I navigate the components, you see that I've gotten a top folder, which is the top namespace that we defined with setting the workspace name. And we have the greeter folder, and in there's some code. So what's recommended is to, not required, but recommended is that you add you add one or more modules in this folder, It doesn't have to be named core. You can rename it if you want. And then you can treat the dunder here, the dunder init, as the interface for that particular component. So if you have a bunch of code but you want to expose one or two functions, then you can define that in the init.py file. It's not required, but it's very much recommended, because each component will have its own little API that you can manage. Another thing that has been added is a tests folder, actually. So if we navigate that, you see that it has a very similar structure, besides starting with test, and it has created a test file for that component. And this is really good if you're into like TDD or or unit testing. So you get some structure for free. But if you don't like this, you can turn that off. There's a flag, there's an option in that workspace terminal that you can turn off adding test automatically, because maybe you want to do that for yourself in a different kind of way, then it's totally fine. So you just disable that thing. Okay, so I'm thinking about, oh no, what did I do? Like that. I'm going to run the following for command again. So you see, it now has noticed that we have a new brick or a new component called greeter. Yes, did I forget something? Well, that was a little bit about the commands. How you get information, how you can see the kind of the state of your source code, and also how you can start up from zero, or continue working, adding components and things like that. You can still, of course, you prefer do all of this in your code editor. The tooling is there to help out, to help you with that, but it's not a requirement to use the tool. So I'm going to go back to my I'm going to show you one thing before. So all the code lives on GitHub. It's this repo, and you'll find the source code. You will find some information, and also the documentation for it. So you can read about some of the things that I showed you, how to install and set up, and and all of the commands available, and configurations, and also a bit more detail about the actual workspace. You can also read about how packaging and deploying guidelines on how you can package and deploy your individual services or apps or microservices or whatever kind of app you are about to build. There's also a section on how to migrate an existing code base to Polylith. So there's a guide that you can check out if you think this is interesting. And I think more importantly is a guide on how to migrate away from Polylith. Let's say that you find that this thing isn't for you, then the design idea for this tool is that should be easy. So it's a one command, and then you're done. And there's a couple of examples. These ones are the ones that I've showed you briefly here. You can see the source code. Both of them are on GitHub. There's also videos about 15 minutes and a couple of articles. And there's also a podcast, an episode on Talk Python, where we talk about monorepos in general and Polylith in specific. So that was the documentation, and I'm going to hit back to my slides here. Yes, I want to show you some feedback that I got from users. Python teams actually already using this, both open source and in-house projects. So I'm really happy to have received this kind of feedback. It's very inspiring and encouraged me to continue working on it. But to be fair, I have also received feedback that is not that positive. And maybe it's not that as inspiring as the positive feedback, but I think it's good to get to learn about how teams view code and what they think about Python in general. So I think this kind of maybe not always that friendly feedback is very useful for me as a developer of a tool like this. And so we reached starting to reach the end of my talk. And so to summarize, I've been talking about trying to clear out the terminology. What's a monorepo and how does that relate to monolith and microservices? I've talked a lot about the Polylith architecture, what it is and how it can solve some trade-offs with the very common setup that many Python teams have, and also showed some examples and some CLI commands and a little bit of code examples too. And that's basically it. Thank you for listening, and I'm really happy to have been able to share the ideas of a Polylith here on this conference. Thank you.